All right, so what we're going to be doing today, guys, is our acceleration lab. I kind of showed you this setup yesterday. You're going to have a ramp, okay, and you're going to be sending the carts down the ramp, okay. So we're looking for the type of motion. Okay, the problem is what type of motion is experienced by a cart rolling down an incline. Remember that needs to be put in your own words in the form of a question. It doesn't need to be significantly different than that. Okay, it just needs to be there in your own words. Okay. Now, for the design, remember that we need to not only identify but also explain, okay, what our variables are in this experiment. Okay. So, in this experiment, we're going to allow the cart to travel down the ramp. Okay? Now, what we want to look at here, okay, is both its position as well as its velocity as it travels down the ramp. Okay? Now, I've actually changed this up. We're only going to do one trial. It's going to make it like super fast. Okay, so you only have to run the cart down the ramp once. Okay, what we're going to be looking at here is we're going to be comparing position and velocity as a function of time. Okay, you're going to be making two graphs. Time is going to be on both of them. Right? Because in this experiment, we, as the experimenter, are determining how long the cart is allowed to accelerate for. That makes it a certain kind of variable, by the way, in case I haven't been obtuse enough. Okay. What we are measuring, as well as time, okay, but what we are measuring is the position of the cart and the velocity of the cart 20 times per second. We're going to get lots of points on here. Okay. What we're looking for is how does the position change as a function of time, and how does the velocity change as a function of time. Is it possible to have more than one responding variable? Absolutely. Maybe in this experiment there are multiple responding variables. Okay. Now, in order for this to be a valid, or let's say, that's the word I'm looking for, controlled experiment, okay, some things need to be consistent or constant during the acceleration. Okay? So when you're looking for these control variables, think about things that might affect the acceleration of the cart, because we need that to be constant. Okay? The acceleration of the cart needs to be a constant in this lab. We want uniform acceleration here. So I want you to think about all the things that could affect the acceleration of the cart as it goes down the ramp. One of those things could be the thing causing it to go down the ramp. You're not pushing it, by the way. You're just letting it go. Something else is going to do all the accelerating for you. It's the stupid thing that's always around, holding you down, holding you back. Okay? Yeah. All right. Everybody with me there? Okay, 3 controlled variables, how you're controlling them, why you're controlling them. The how can be, I can't do anything about it anyway. That might go along with that thing that's pulling it down the ramp. Okay, make sure you tell me how and why your manipulated variable is being manipulated, how and why your responding variables are responding. Okay. All right, for your hypothesis, okay, what 3 words go in the hypothesis? If, and then. Okay, the if part, okay, describe or define acceleration. If acceleration is blah, 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 blah. Okay, don't write blah, 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 blah. Okay, you have to fill in the blank there. Okay, so if acceleration is. All right, the and part always describes the experiment. Okay, just briefly, a cart's going to be allowed to accelerate down a ramp with its position and time, and position and velocity is recorded. I don't know, something like that. That's what we're doing. Okay, the then part looking for a couple of things. Remember, in the then part, you're supposed to say what your predicted results will be and what you can do with them. So, what I'm looking for in the then is for you to predict the shapes of both graphs, so of your position versus time and velocity versus time graphs, and tell me how your velocity versus time graph can give you acceleration. You might want to look back on your first lap. It might be something like that one. Okay. And we talked about how velocity versus time graph would give you acceleration several times throughout this unit already. Okay, so that's what I'm looking for the hypothesis. Something wrong with that?
It's taking a while to load.
They know when I'm coming. They sense me. Okay, so here's what we're going to do. I need you guys to build your ramp, get the cart set up. You're going to be letting it go down the ramp, okay, using the SparkView app. If you've forgotten how to use that, that's fine. Just come in and I'll show you again. Okay. What we want is for you to run that cart down the ramp, have someone stop it at the bottom. Please don't let it go off the end of the ramp. Okay. If it goes off the end of the ramp, it can damage the wheels and the sensors and everything inside. So please, one person's job is just to stop the cart. If you're that person, you have one job. Stop the cart before it goes off the bottom. Okay. So just let it go down the ramp, okay, and then we'll go through what the data is going to look like, okay, what we have to take out. Basically, all you want to be left with is the time, position, and velocity for that one trial. You're going to delete everything else from that big, messy spreadsheet that you get, okay, and then you're going to build a position versus time and velocity versus time, but we'll go over that after you have your data. Collecting the data should literally take less than 10 minutes. You're making a ramp, you run the cart down the ramp, and then you're putting it all away. Okay, it's super easy. The ramp does not need to be that steep, nor should it be. The steeper it is, the less points of data you're going to get, because the faster the cart will get to the bottom. Okay, I would say I wouldn't make the height of it more than 20 to 25 centimeters. Okay, if you make it taller than that, you won't get solid data. You want it to accelerate, but accelerate slowly down the ramp so you get more data points and your graph looks better. Okay, so 20 centimeters high, that's a good number for the acceleration. Okay, more than that, it's going to be really quick. Okay, questions? All right, there are 8 ramps, 8 carts. Off you go. Okay, if you need some help with setting it up, let me know. So guys, remember that when you get that data sent to you, it is going to be a CSV, or comma separated values file. Okay, so it'll look something like this. And when you try and open it, okay, it's going to be a mess like this. Well, except yours will be a bigger mess because mine's got less data. Okay, and what you want to do is open it with Google Sheets. That's probably the only option available to you because you're on a Chromebook, because this also has Excel on it. That's the default program. So just open it with Google Sheets, okay, and then you will get a different kind of big mess that looks like this. Okay, same as what we got the last time. So you've got some thinning to do. All you need to keep for this lab is the time, the position, and the velocity columns. Everything else you're going to delete. Okay, so I'm going to get rid of that column. Okay, and then I got a whole bunch of columns I'm going to get rid of. Don't need force. Okay, but I'm going to keep position. Velocity's right beside it. I don't need any of the other columns. Okay, now your best bet for being able to build two graphs is actually to make two sheets. Okay, so I've got sheet 1 that's called acceleration data raw, just because that's what the file name was. Okay, I'm actually going to call it something different here, just so that I get kind of the right idea, and I'm going to say position time data. All right, and then what I'm going to do is actually make another sheet to put the velocity and time on, so that I get two separate graphs. Right, so I'm just going to hit the plus button. It's going to make a new sheet. Okay, I'm going to get out of there, go back to my position time data, and I'm going to copy the first column. And then I'm going to go into my second sheet and paste it. Okay, and then I'm going to go back to my first sheet, and I'm going to cut the velocity data out, and I'm going to paste it into the second sheet. Okay, so now on one sheet I've got time and position, so I can build a position time graph, and on the other sheet I've got time and velocity, and I can build a velocity versus time graph. Okay? Now, the only thing I have to be careful of here is when I get to my data and I start trimming out the stuff that's not important, I have to make sure I trim the same data from both graphs. Okay? So, what I'm going to do is build the position versus time graph. Okay, so what I got here, this part here is not great. I probably don't want that. That's probably after I stopped it over here or was slowing it down. Okay, because I used a much longer ramp when I did this. Okay, so this is probably when it hit the sweaters I had at the bottom to keep it from going off. It was just me. Okay, so I only want this part here where I can see, okay, that it's actually accelerating, that it's somewhat curved. It might even be easier to see that on my velocity time data. So I'll build that graph at the same time, and then I'll know which points I'm going to pull off of both. Why did I pick that data? Okay, so I'm going to just take this first little bit here. My data is terrible, guys, because I just found the only file I could find. Okay, hopefully your data is better than mine, but this is the only part of my data where the object's actually accelerating. Okay, is for this first half a second. Okay, so what I'm going to do, your data is going to be better than mine because I had to do this by myself. Okay, your data is going to be better. What I'm going to do is I'm going to take for mine and I'm going to get rid of all of the data that's not accelerating. That's everything after 0.5 seconds. And then I'm going to take off the same points on the position time data. So I'm comparing exactly the same amount of time for both. Everybody follow me there? Whatever you take off of one, to make sure you take it off of the other graph as well. Because in the analysis, you're going to be asked to compare the two, and they have to be a fair comparison. They have to be about the same interval of time. Okay? So for me, that's going to mean going back up here, right, and taking everything after 0.5 seconds off. Okay, so there's my acceleration data. It's pretty crappy. Yours will be better. Okay, and then I'm going to do the same thing for my position time data. I'm going to take off everything after 0.5 seconds. So that now my two graphs are showing exactly the same data. Okay, everybody with me there? Now I've got those two graphs built. For the position versus time graph, hopefully yours curves a little more than mine. Okay, mine's not a very good acceleration set, but you can see that it does curve upwards slightly, okay, which is what it's supposed to do. And then my velocity versus time data is nice and linear, exactly like it should be. Okay, so for your velocity versus time graph, put the equation on that. You don't put the equation on your position time graph. Okay, you can draw a best fit line on both, but you only need the equation for the velocity time graph. Okay. All right, I'm going to give you guys a few minutes to kind of get the graphs built, and then I'll talk a bit more about the analysis after that, so I don't overload it. Okay, guys, let's just quickly talk about your analysis here. So you're obviously building a position versus time graph. You can put a trend line on there, okay? But you don't want it to be linear. So if I'm looking at my graph here, okay, of my position versus time data, okay, when I go to put my trend line on there, okay, so I'm going to put my trend line on there, but I don't want it to be linear. Okay, it should actually be exponential, so it's going to go like that. Okay, because it's a curve, it's supposed to be. It does follow my points really nicely. Okay, that's what that one should look like. Don't put any equation on there because we don't deal with exponential functions. It's just going to make no sense anyway. That's all you need for the position time graph. Okay, for the velocity versus time graph, okay, put your trend line on there. Okay, that one you want to be linear, that one you want the equation for, so your graph looks like that. Okay, I mean your numbers, your slope is going to be different, and that's fine. Your y-intercept's going to be different, and that's fine. Okay, everybody with me so far? So your graphs should look like that. You're going to copy them and put them into your Google Doc. Okay, both of those graphs need to go in the Google Doc. Your data does not. Okay, don't put your data in there. I don't even want to see it. I just want to see the two graphs. Okay, so put those in your Google Doc. Okay, and then we'll talk about the analysis here. So in the analysis, question number 1 is just explaining. Okay, that's all you have to do. Right? So using your graphs, identify the type of motion that occurred. So tell me, my position versus time graph has this shape. This means it was doing this, or this means it was accelerating because. Okay? The velocity versus time graph had this shape. That means the object was accelerating because. So there's some explaining there. Okay? And then it says, show calculations to prove and explain your reasoning. So those calculations are only from your velocity versus time graph. Okay? This goes along with your hypothesis. This will be the proof for your hypothesis. Okay? There's something on that graph that is equal to your acceleration, and you need to show me the calculation for it. Okay? It's really not that hard. Okay? You just have to get it from your graph / equation. Okay? And that's all you have to show for the calculation. So you're going to have some explaining, okay, where you're going to say the position versus time graph indicates acceleration because, the velocity versus time graph indicates acceleration because, and here's the mathematical proof from that graph. Now, question number 2 involves a little bit more work. Okay? In question number 2, you are going to calculate the object's displacement from both graphs. Okay? You do that differently. Okay? On a position versus time graph, you calculate it one way, and on a velocity versus time graph, you calculate it another way. I will remind you that you may have a formula that we just learned that could calculate the displacement using numbers only from the equation of your velocity time graph to get you your displacement. Okay? So if I'm looking at my equation here, okay, if I remember what this stands for and what that stands for, I can use them in one of the formulas we've been working on the last few days. It'll calculate displacement right off. Okay? And I can compare that to the displacement from my position versus time graph. How should they compare? When I calculate the displacement on one graph and then I calculate it from the other graph, how should they compare?
They should be the same.
They should be the same. Now, they may not end up like right down to the nearest like centimeter the same, but they should be really close. All right, like realistically, you should be within 5 centimeters when you do this calculation. If you're out by more than like 10 or 15, you did something wrong along the way. Okay, that's why I had you make sure you removed and only graphing the exact same interval on both graphs. Okay, if you don't do that, then you don't get the same number. All right, so for that analysis question, okay, calculate both values, compare them, and explain why. Okay, that's your analysis. Conclusion, same as before, copy paste your hypothesis, explain to me, does the data accept or refute your hypothesis? Okay, did the graphs look like how you predicted? Were you able to calculate the acceleration in the way you predicted? Okay, was it valid? Explain. Okay, and then 2 sources of error and how to fix them. Okay, think about how that cart went down the ramp. Think about if you heard anything as it went down the ramp. Okay, those things might indicate stuff that was happening as it went down the ramp that may not have resulted in getting a perfectly uniform rate of acceleration. Okay? All right, questions from you guys? All right, I'm going to shut up and let you do the rest of the lab report. Okay, that's what you got to do. Okay, with those graphs. The due date for this is on March the 11th, so that's Monday. All right, so you got this whole week to come in and see me if you want me to look anything over.